Hello, this is Team 45 and we're going to present our Airbnb price prediction. Airbnb is an online platform for listing and renting local homes. It's popular these years as many renters and tenants join its platform. One problem that is commonly faced by renters and tenants is pricing. They want to find the appropriate prices that will satisfy renters and tenants. The price of a commodity is usually predicted by its component attributes. Previous works of rental price prediction include statistical methods, clustering, sentimental analysis, and supervised learning. Our problem is a regression problem, and we want to predict the price of Airbnb based on several attributes.
And we find our dataset from Kaggle website. It is the public Airbnb dataset, and it consists of 16 features. For data cleaning step, we remove null attributes with dummies. We also filter extreme values to normalize data distribution. We also visualize the features and drop irrelevant columns. Here are some examples of the data visualization.
We also did feature engineering. We first applied log transformation on continuous features, as mentioned by Liu's paper for house price prediction. Then we try to use sequential feature selector and PCA to select relevant features, and we hope to increase our model performance. We use lateral regression to test which feature and feature transformation we should use by selecting a subset of features or feature transformation that gives the lowest MSE error. Here is the experiment result of sequential feature selection. We test the MSE error on 5 train test splits of testing data. We find that we should keep all features or it will increase the MSE error for lateral regression. We also assume that if keeping all features works best for lateral regression, it also works best for all other methods. Here is the experiment result of PCA transformation. Similarly, we find that we should keep 60% of dimensions of PCA for lateral regression. We also assume that it will also work best for all other methods.
Unsupervised learning can capture various patterns within the dataset, and it has proven to be effective from the past literature. In our dataset, we apply KNN, GMM, K-means to the dataset. We utilize KNN to 3 different forms of the dataset, and the respective result is shown in the table below. The dataset in the last 2 rows perform worse compared to the first one, due to the fact that they contain many more features, making the prediction of the price more complex. We also have some interesting findings using GMM. When we cluster the data with price only, most of the purple and pink data points are clustered in Manhattan and Brooklyn. Outside these areas, nearly all the data points are orange. We also utilize K-means to our dataset. We use the elbow method to optimize for the number of clusters, which is shown in the graph on the left. We selected 3 as the appropriate value, and then assign each row of the dataset a label based on K-means clustering, which is shown in the picture on the right.
We use linear and polynomial regression for our supervised learning. Linear regression is a linear approach to modeling the relationship between variables. Polynomial regression is the relationship between the independent variable x and the dependent variable y, and it is modeled as an nth degree polynomial in x. We choose degree of 3, and compared to linear regression, polynomial regression has a better approximation.
The supervised method, we also tried ensemble methods. We tried ranting forest first. If the results are determined by votes of many decision trees, and it tries to lower the variance. We also tried ADA boost. It focused on the large error data for the next decision tree to train, and it tries to lower the bias.
We also apply SVM to this regression problem. We use 3 different kernels, including linear, RBF, and polynomial. Usually, linear and polynomial kernels are less time-consuming, but they provide less accuracy than RBF. But for our dataset, they have similar performance. And for the neural net, we'll use MLP regressor model.
For these supervised learning models, we trained on trained dataset which contain 80% of the data and evaluate on testing dataset which contain the rest 20%. The performance is evaluated by the root mean squared error, mean absolute error, log mean squared error, and R2 score. We train and test model of unclustered data and clustered data. For the clustered data, the cluster information is determined by k-means for trained dataset, and we use k-layers label to determine the cluster information for testing dataset. Here is the experiment result of supervised learning results. The figure on the left is the result of the unclustered data. We find that the random forest performed the best. The figure on the right is the experiment result of clustered data, and we also find the random forest performs the best. We also compare it with the results from unclustered data, and we find that training and testing each model for each cluster performs better.
Overall, we achieve a good score comparing with other Kaggle notebook results. We use R2 score to check how well observed results are reproduced by the model. A higher value of R2 is desirable as it indicates better results. Our linear regression has R2 score of 0.045 and its cluster has RT of 0.046. Compared to from Kaggle, it only has RT of 0.075. Our random forest unclustered has RT of 0.52 and cluster has RT of 0.56. Compared to the decision tree model from Kaggle, we have RT score of 0.25, and the best overall we see from Kaggle is RT equals to 0.62. The potential impact of our model is to help owners and customers with Airbnb price evaluations in New York City.
Thank you for watching.